we are going to be talking about probability. Does anybody have a guess of what probability might mean?
Is that like the, I thought it was like the absolute value, but yeah.
No? Who else has a guess?
Can you give us a hint?
Okay, something like this. Say you were to go skydiving. I don't know the exact probability, but the probability of your parachute not working is like 1 in a million, okay? Is that a high probability? Will it probably happen or probably not?
Oh, is
Probably
that
not,
the circle?
okay? So probability is almost, do you have a guess?
It's like the chance, yeah.
The chance of something happening, okay? So today we're going to talk about 2 kinds of probability. Write down these formulas for me, please, and then we will talk about those 2 kinds of probability. Okay, so the first formula that I have here is theoretical probability. Do you guys think you know what theoretical means? Theory. What does theory mean?
Like a hypothesis.
Like a hypothesis, okay? So almost like a guess. You're guessing that something might happen. In theory, it seems like this would happen. So what you would do is you would take your favorable outcomes. That's kind of like, favorable means the thing that you're looking for, okay? Out of the total is obviously the total outcomes that could happen, okay? Experimental is a little bit different. What does that look? That looks like what word? Experiment. That means you're actually doing an experiment to see if something will actually happen. Then you'll see the number of successes. That means how many times it actually happened, the thing that you're looking for, over the number of trials, the total number of times that you did your experiment. Okay, so let's look at an example for number 1. Okay, so for this right here, we are going to be doing theoretical probability. The reason why we're guessing in theory of what will probably happen. We're not actually doing an experiment, so that's why it's theoretical. A bag contains 3 blue, 4 green, and 3 red marbles. Find the probability or the likelihood of randomly choosing these colors. So let's just imagine right here. Find P. What do you think P stands for? Probability, okay? So find the probability that if I stick my hand into that bag, I will pull out what color? Blue, okay? So favorable outcomes over total outcomes. The favorable outcome is going to be if it's blue. What are the chances? How many favorable outcomes could it even be a blue? 3 of them, okay? So that's going to be 3 over the total. How many total marbles are in that bag?
9, 10.
How many total are in the bag? 10, okay? Because you've got to count that blue one that we're talking about too, okay? So there's 3 out of 10. What would that be as a percentage?
0.3.
30%. 0.3 would be the decimal, okay? Then that's 30%, all right? So you could write it either way, 3/10, 3 out of 10, or 30%. Now let's go to the next one. Once again, we're still doing theoretical probability because we're not actually doing an experiment. Find the probability that it's going to be a red marble. So if I stick my hand in there, what's the favorable number that it could be red?
3.
Oh, 3.
How many reds are there?
3.
3, okay? How many total marbles are in that bag? 10. So this looks very similar to if it was a blue. What percentage is 3/10? 30%. All right, let's look at the next one. Find the probability that if I put my hand into that bag, I would pull out a green marble. What's the favorable number that it could be?
4.
It could be 4 out of what's the total number possible? 10. Can that be reduced at all?
Yes.
Yes, to what?
Oh, 2/5.
2/5, okay? When you're doing it as a fraction form, you always want to make it in simplest form. 2/5. If out of 5 that I put my hand in there, 2 of them are going to come out green, what percentage is that?
40%.
40%. Okay, so probability can be written like this, 2 out of 5, or it could be written as a percentage, 40%. Okay? Let's go on to another example.
Is,
Number 2 says, each letter in the word Mississippi is written out on a separate piece of paper and put into a bag. You randomly choose a piece of paper from the bag. Find the probability of the event. Write the probability as a fraction, okay? So out of this word, I remember when I was a kid, I thought it was so cool that I think it was in like 1st grade, that I knew how to spell this really long word, Mississippi, and we would chant it back and forth, M-I-S-S-I-S-S-I-P-P-I, and I was so proud of myself, okay? So today we're going to deal with that word, Mississippi. What is the probability that I would choose an I out of Mississippi? Theoretical probability, favorable over total.
Oh,
What's the favorable number that it could be an I? 4, because there are 4 I's in Mississippi. Favorable over total. What's the total number of letters? 11. Can that be reduced at all?
no.
No, all right? It only asked us to write it as a fraction. So 4 out of 11 chances that it would be an I. I want you to do the next 2 on your own. Addison, what is the probability that we would choose an M? Favorable over total. 1 out of 11 chances that it would be an M. Good job. Next up, Tati, what's the probability that it would be a P? 2 out of 11. Who got both of those correct? All right, excellent. Let's go to the next one. Okay, so let's say that we roll a number cube. How many of you have seen a dice before? Okay, who can tell me a game that you play that uses dice? Monopoly.
The math game played.
Okay, we've played math games with them before. Kayla.
Some card games.
Some card games, have you used it?
Is it Yahtzee?
Poker.
Is it Yahtzee?
Poker you do. Yahtzee. Yahtzee is nothing but dice, okay? So let's just imagine, like this right here that I've got. You've got a number cube. Write the probability as a fraction, a decimal, and a percent. Let's talk about this right here. How many numbers are on this cube?
6.
Oh,
There's 6. What numbers are they?
1, 2, 3, 4, 5, 6.
1, 2, 3, 4, 5, 6. So my first thing that it's asking me is find the probability that if I rolled this right now, that I would get an even number. How many even numbers are on this dice? There's 3 of them, okay? What are those even numbers?
2, 4,
2, 4,
6.
2, 4, and 6, okay? 3. So that is the favorable, the amount that could be even numbers. Out of the total, how many total numbers are on here? 6. Can that be reduced?
yes.
What is it?
1,
1/2,
yeah,
okay? What percentage is 1/2? 50%, okay? So if I was to do that as a decimal, it would be 0.5. If I did it as a percent, it's 50%. Okay, once again, you will always put it in simplest form for your fraction. Let's go on to the next one. Find the probability that I would roll a 4. What's the favorable outcomes? How many 4s are on there?
4, 1.
1.
There's only 1 4 that's on there out of how many total numbers? 6. What is the decimal for 1/6? You can stick that in your calculator if you don't know. It's not 0.3 repeating. Put it in your calculator.
I thought it was points repeating.
0.16 repeating. Okay, but I only want 2 numbers. So what would 0.16 repeating be? Not 0.16. 2 numbers.
0.16.
Listen, if it's 0.166666, what would that be rounded? 0.17. Okay? So now, as a percentage, what would that be? 17%. All right? That's if you needed all 3 of them. Okay? So make sure you always round it correctly. Okay? You're going to look at that third number to round the second number. You will always round to having 2 numbers. Yep. To the nearest hundredth. Okay? Next up, find the probability that the number is less than 5. How many numbers on this die are less than 5?
4.
4 of them. A 4 is less, a 3 is less, a 2 is less, and a 1 is less. So 4 out of how many total?
5.
Out of 6. Can that be reduced?
2/3.
To 2/3. What's the decimal for 2/3?
0.666.
0.666. So what would that be if I just want 2?
67.
0.67, which would be what percent?
67%.
67%. Okay, good job rounding that one. All right, so that is as a fraction, a decimal, and a percent. All right, this next one here, this one is actually going to be experimental because somebody did the experiment, okay? So here's what it is. A cat knows that the shake command, a cat that knows the shake command offers either its front paws to shake. So we got to figure out whether it's going to be the right one or the left one, basically. So find the probability that the cat will offer its right paw, and then we'll do its left paw. Great. So this was an experiment because somebody actually did experiment with this, all right? So they had this little cat, and they said, "Here, kitty, kitty, kitty," and they asked, "Please, shake my hand," or whatever. So the probability that this cat puts up a right paw. What are the number of successes that it was a right paw?
Oh, 12.
12 successes that it was a right paw. Out of how many times did this cat do this? 50. How'd you figure out that number 50? If you add these two together, that gives you the total number that they tried this cat putting its paws up, okay? Can that be reduced at all?
Yes.
Cut it in half, what would it be?
6/25.
6 out of 25, okay? So tell me what that would be as a percentage.
24%.
24%. There's a 24% chance that this cat, or there's a 24% actual probability that it did put its right paw up, okay? Because this was an experiment. So let's go on to the next one. Left paw. What is the probability that it actually put its left paw up?
38 out of 50.
38 out of 50, and what is that reduced?
19 over 25.
19 over 25, and what percentage is that?
0.7 means 76%.
76%. Now, do you guys notice anything about these two percentages right here?
They all equal
They equal what? 100, because there's 100% chance that it did something because it did do something, okay? So you can always add that up. You can also see this right here, 6 and 19. What do those add up to? 6 plus 19.
25.
25, okay? So out of 25, it did something 25 times, okay, which is 100%, all right? So how many of you have a cat?
Ooh, I hate
How many of you do not have a cat?
that's scary.
All right, now let's just think. Cats can do some pretty silly things at times. We're going to look at something right now that a cat could do that might be a little bit silly.
Oh, I saw this video.
That's a pretty talented cat right there, isn't it? All right, so that one actually did show tricks. Most of the time you think of dogs doing tricks, not necessarily cats.
Oh my gosh.
All right, we're going to do one last problem for today. This one is also experimental because they actually did this experiment. Of the 20 voters polled after an election for class president, 14 of the voters voted for Sean. What is the probability that a randomly chosen voter actually voted for Sean?
14.
I want you guys to go ahead and talk about it and try to see if you can come up with the answer. Okay, so I had someone who got 70%, somebody who got 30%, and somebody who got 73%. Let's try this out. Let's see what makes sense. Okay? Look at this. There are 20 total voters. 14 of them voted for Sean. Let's just think about this. Out of, ladies, listen. Out of 20, what would 50% of 20 be? 10. What's half of 20? 10. 50%, okay? So if this number right here had been 10, the answer would be 50%. Is that number bigger or smaller than 10?
Bigger.
Bigger. So it makes sense that your answer is going to be bigger than 50%, okay? So which one of those answers that you guys came up with definitely cannot be true?
70. I mean 30.
30%, it cannot be true. So now we've got two, 70% and 73%. It could be either of those, but let's just test it out and see what we come up with, okay? So this is an actual experiment. They went around, let's say I went up to a class of 20, and I went up to one random person, and I say, hey, did you vote for Sean? Out of those 20, how many people did vote for Sean? 14. That right there is the number of successes, people who voted for Sean. How many total people voted? 20. Okay? Reduce that. Basically, you cut it in half. You get 7/10. What percentage is 7/10? 70%. 0.7 is the decimal. 70%. Okay? So this one was not correct, but this one was our correct answer. There's a 70% chance, or a 7 out of 10 chance, that that person voted for Sean. Okay?
And I get it.
Okay, so here's the thing. What you got to do is look at the question. It says, what is the probability that a randomly chosen voter voted for Sean? So that means the thing that we're looking for, the successes, is who voted for him. So out of looking for that, we can see 14 of them voted. So that's why we did 14 over 20 instead of the opposite, the 6 over 20. If we had said what was the probability that he did not vote, it would have been 6 over 20 or 3 out of 10. Okay? Tomorrow, we're gonna be doing experiments in class where we are actually doing experimental probability, where we are testing out of our trials how many successes we get with that, okay? Today, I want you to go ahead and write down this. This is your homework assignment for tonight. It's 10 problems, so go ahead and write that down.